Hi guys, welcome to Learning Electronics Repair. This is the little op amp tester I built, well over a year ago now. About 380 videos ago, in fact, I had a look, yeah. And this was meant to be a PCBWay project, but never quite got that far. This was built on Vero boards. And what we have here is a single op amp tester and a dual op amp tester. It's very simple. You plug an op amp in, it runs from a single supply rail. I use 9 volts, but it's not critical. 9-volt battery would work great with this though. And if you put the single op amp in, if it's good, it flashes the LED. If it's bad, it don't. Yeah. Same, you put a dual op amp in here. If both sides, both op amps are good, it flashes both LEDs. Or it flashes just one if the other one is defective, or none if they're both defective. And we can also build a quad op amp tester. These just use the same circuit as each other. In this case, there's one instance of the circuit. In this case, there are 2 instances for each of the op amps, and the quad tester would have 4. And I built this, put it on one side, may have dragged it out once before, and then a couple of days ago, I was repairing a powered amplifier from an active speaker. I'd unsoldered the op amps, 2 of them, and I thought one might be faulty. And I actually used this to test it, and it proved the faulty LED was faulty on one side. The other side was okay. It was a dual. And I replaced the op amp, and the thing works. So this proved its use, yeah. What I want to do now is expand this project in a couple of different ways, well 3 actually, explain what I'm doing. I want to show you something, hopefully this is going to work, because I did have one major limitation using this tester. So the tester was a shared project from PCBWay.com. As well as being able to order PCBs for your projects here, this is a great place to share your projects if you wish. So you can upload your project, the schematics, the Gerber files, bill of materials, firmware, source code if you want to. Basically whatever you want to share for that project. And if somebody wants to build the project, then they simply order the PCBs from PCBWay.com using your Gerber file, and they can build it. This is why, of course, you should upload the schematic and layout, or at least explain where they need to put each component, okay? Basically, the more information you give to the prospective customer, if you like, the more likely they will be to build this, I think. The great thing about this is it doesn't cost you anything to do so. You share your project, and at any time somebody wants to build that, they order the PCBs, and you will get a 10% commission from PCBWay. I've sold quite a few PCBs from my projects, and I haven't uploaded many, less than 5 probably. So this definitely works, I can tell you. It will not make you rich overnight unless you design something amazing, but it adds up over the year, that is for sure. And of course, the more you design, the more you upload, the more you may earn. So on PCBWay.com, we can search for projects either under categories and browse, or we can search using the little search bar, as I did, and I found this one. So this is Inside Guy, another YouTuber, very popular and very clever guy. He's made a number of projects on here, and this is a simple dual and single op amp tester. This is similar to the one that I use, slightly different. He uses a 3rd op amp to generate a dual supply rail, whereas I just use a single supply rail, okay? So this op amp is fixed to the board, and these are on the sockets. These are the ones you can test. And you can test 2 together if you so wish. So the version I built was similar to this one, but was designed from another project that uses single supply rail. So the one I have, you can just run from a 9-volt battery. You can see here, very easy, or connect it to your bench power supply. So it doesn't have to be 9 volts. It works on quite a wide voltage range, actually. The main problem with this project is there was no real schematic as such. There was this kind of layout. So from that, I actually engineered the schematic, which means I can actually make my own PCBs This is the actual schematic, and we have one of these for each op amp we want to test. When I say for each op amp, for a single op amp tester, you need one of these. For a dual op amp, you have two, you just duplicate them. And for the quad tester, you have 4 more. You can see this uses a few 10k resistors, a couple more resistors, a couple of diodes, one M4001, but any silicon rectifier diode will work here, one 10 microfarad capacitor. And again, you build as many of these as you want to test op amps. So if you want a single plus dual plus quad op amp tester, you need to reproduce this 7 times. The tester is very simple to use. Here is a dual op amp, for example, LM358, and we just hold it against the socket, make a connection, and if both the LEDs flash, it's good. Okay, simple as that. Although it will test op amps, what it won't test, by the way, is comparators. So this is pin for pin compatible. Well, that doesn't test, okay, and we'll just come to that shortly. So comparators it won't test. Op amps it will test, okay? And if we built the 4-channel version, we could test quad op amps, we can test single op amps. So that's the basic tester. Now, I used this to test some op amps from amplified speakers, as I say, but they were surface mounts. So to test the surface mount op amps, I had to desolder them from the original PCB. Solder them onto a breakout board similar to this one. Okay, so you can get breakout boards for various options. This is small outline IC. Okay, so solder it onto there. You can then attach this onto the tester to test them, and then if they're good, desolder it, solder it back onto the board you took it from. Now that is a bit of a pain in the ass, but it works. You can also use adapters like these ones. So with these, you kind of press it down, drop the chip in, let it go, hope it makes a good contact, and again plug that into the actual socket, hold it on there and test them. Yeah, so that's a couple ways of doing it, but these are a bit fiddly to use as well. So what I wondered is, can we effectively use this to test surface mount op amps without that messing about? And I think we can, but there's a few considerations. So the first major upgrade I want to make to this is this thing. So I've lashed this together to prove the point. This is a breakout board. Okay, you can see a dot pin 1. I have 8 wires attached to this thing, and I can plug this into my op amp tester. Okay, what I'm hoping now is I can literally just hold a chip against this, push against it, make a good enough contact to actually trigger the tester. So let's see if that actually works. So here is a 4560 op amp, one of the ones I actually used to repair that amplifier. So what I'm going to do is to literally just hold my op amp against here and see if it actually makes a contact or not. With it powered up. Right, so I don't think I'll actually really short against anything. This is going to prove it. And we'll talk about that in a minute. Yes, so I almost had it. Let's see. So how easy this is to use, okay? And yes, I have it. So I'm just holding the chip against there, and we see both LEDs flashing. Yeah. So that is a proof of concept, and it works, okay? So you can do that. Now, that was a bit fiddly. What I had in mind was a little bit simpler than this. So I was intending to build a PCB version of this, which just has an area where you put your chip. So effectively, we don't have these contacts here or here to get in the way. We just have the 8 pads. Now, one of the considerations I had was that you could short something out on here, and I'm not sure exactly how you would do it, but if it can be done, it will be done. So this pin is your VCC. That's the 9-volt supply you have coming in, okay? This one is the ground pin, so it's a bit difficult to get a short there, but I guess you might short the power pin to one of the other inputs or something. So to prevent any sort of chance of shorting this thing out, I think if we power this via a constant current source, which gives just enough current basically to test the op amp, we'll measure that in a minute, then we can effectively, fairly safely do this. It might be possible also just to stick something across the PCB, so it has like a little bit of a ridge here and here, so effectively you slide this in, you can't move it up or down particularly. That might also help actually. So I think there's a few things we can do to mitigate any problems while doing this, but certainly putting a constant current source on is one of them. So let's have a look to see how much current this thing actually draws. The easiest way to do this would be just to plug in a chip again and then add a bit for the quad. So we know this is a dual one, okay. We have the multimeter, we'll just check it should be a 9-volt supply. Yeah, 9-volt supply. Now let's measure the current that is drawing. It draws about, well, it's changing a bit, 10, something like that. Let's say with a quad op amp it might be 20 milliamps. So if we could do one of two things, we could basically increase the value of the resistors that are feeding the LEDs to reduce the current, or we could set our constant current source, as we say, to about 20 milliamps. Hopefully that is not enough to blow up op amps, okay. I think once this thing is obviously a larger PCB which has these sort of sockets on there, and it also has this etched onto the PCB, if we put like a piece of printed vinyl over with cutouts just where the chips go here, if the vinyl is maybe like a millimeter thick or something, we'll probably have a nice space we can actually drop our chip in without it sliding up or down, okay, make it a bit easier to actually hold it against the pad. That I think would work rather well also. This is the actual schematic I was showing you there off my old video. You can see it much more clearly now. And these are the standard pinouts. So with a single op amp, we have the inverting input on 2, non-inverting on 3, output on 6, and then 7 and 4 are the power, VCC and 0 volts. This works on a single voltage rail, this tester, even though the op amps may be dual voltage rail, okay. For a dual op amp, there's 2 op amps in there, A and B, so we can see inverting inputs are on pins 2 and 6, non-inverting on 3 and 5, output, so effectively inverting on 2, non-inverting on 3, output on 1, and the part B, the second one in there, inverting 6, non-inverting 5, out 7, and obviously just one set of power pins. And this is for your quad op amp, okay. Again, so you can see for each of the 4 op amps, the 2 inputs, either inverting and non-inverting, and the output. So basically you repeat this circuit 7 times, fitting a 8-way socket, another 8-way socket, and a 14-way socket, okay. And that will test most op amps. There are some quad op amps I've seen that have a different pinout. I think LM3900 is one. But you could, if you wish, build more of these if you want to have a different pinout to suit certain op amps. Just put another socket on your PCB. Okay? So it's quite flexible, and it's used to be, quite honest. As well as my PCB having an area to hold on the surface mount op amps, the 8-pin and the 14-pin, I also come across these type of op amps as well. So This is an 8-pin single inline op amp. There are a number of different models. As far as I can see, they all have a standard pinout. And the pinout matches that of the dual op amps, okay? And you see it here. So it literally is pin for pin the same pin numbers as a standard dual op amp layout, okay? So we can add a single inline 8-pin socket for those as well. We can test those as well. They are fairly common in mixers and amplifiers and such like. I think that's worth adding at basically no extra cost. And while we're at it, I've looked around. I'll probably use one of these type of circuits. We can test the LM393s as well. That's another very common chip that we might come across. So I think we can make a very simple device here, no microcontroller required, just a very cheap and easy way to test some very common parts that we're likely to find on PCBs. And again, we can do the same trick with the LM393 because we quite often see surface mount ones of these as well. Well guys, it's a different day, different shirt and a few fresh ideas. So this was a 4 AM or maybe 6 AM because it's Saturday morning. I popped down the office to finish this video. Yeah. So I had some ideas how we can make this more useful basically, and just wanted to chat a little bit about why I think this design is a particularly good one for this. So what occurred to me is we don't need to build 7 of these. We only need to build 4 of these circuits for testing op amps, okay? And what we can do is make this pretty much modular. So we start with this basic circuit for the op amp tester, okay? And that effectively is a module. So we can call these inputs here -1, +1, and O1 for out 1, or whatever you want to call them, okay? And we can repeat this 4 times. This is our little module, okay, and we have coming out of here, let's put 1 minus, 1 plus, 1 out. So we have 3 connections, should have drawn it better. And if we repeat this again, and again, and again, we can have 2 minus, 2 plus, 2 out, and the same for 3. And 4. We can then take all these connections up here like so. I won't draw all of them, but I'm sure you can see you will end up then with all of them here. 1 minus, 1 plus, 1 out, 2 minus, 2 plus, 2 out, and so on. Okay. We can then take our IC sockets. Now, I did consider the possibility of using an 8-pin socket for both dual and single op amps, or even a 14-pin socket, which would work for all 3 types, dual, single, and quad. But the main problem I see with that is the power is on different pins, and I think trying to do that with this basic tester is more hassle than it's worth. So what we do is we fit our first socket. So this is single, and we can put a little printed image by it so we can see the schematic of a single. So this is 2, 3, and 6 as I remember, with the pins that we need. Obviously they all have power. And then we have our dual op amp with the 2 op amps in, and we kind of, again, we can print a symbol by it. So we basically know how these things connect. Okay. And we do the same with a 14-pin. And that's for the quad. So we got single, dual, quad. And then we just need to connect the various pins up to here. So this is where all our outputs for our modules are. And we just literally run wires down. So, for example, 1 minus could go to here. 1 minus, and also here. 1 minus, and on the quad up here 1 minus, and then 1 plus can go here, 1 plus, 1 plus, 1 plus. So we just literally run wires up to each one. Yeah, we have this as like a row of holes in the Vero board, or on a PCB it's just printed, and we just strap them where we want. I'm sure you can figure out how this goes. So we have 2 minus and 2 plus goes to here, and it also goes to here. I think it's this way round, 2 minus 2 plus. I won't bother look it up. You can correct me if you like. Okay. So once we've run all those wires down there, we could just stick whichever one we wanted to test, and we test it, and we have 4 LEDs, 1 on each of these. Okay. And they will flash 1, 2, 3, or 4. The little adapters for the surface mount on the prototype, which I am going to build on Vero board, I have one here. So I've soldered the pins. It's not exactly straight, but as flush as I can on here. This will now, if I like, fit into the IC socket, and I can test the surface mount ones on top, or I can actually just stick it somewhere close by and solder it to the board. It's probably going to be more rigid that way and better, so that's what I will do. And the same with a 14-pin adapter, which I have to do this way anyways. In fact, this is a 16-pin. I do have some 14-pin ones, but they're wider like this. They won't fit onto the socket, so they have to go that way anyway. I can then just smooth these down with a Dremel. I think is probably the easiest way. I struggle to get them absolutely flush that way, but I can get a good soldered connection under here, and then that'll be effectively flat. Okay. I can then put a little bit of insulation tape or something similar over the actual pads here, something like that. In fact, if I use something a bit thicker than insulation tape, it'll give me a nice ridge either side, so I can just slide the chip in easily. Okay, so that's how we can put those. And again, we just run the wires up to across the top here. It'll be sort of plus minus and out 1, plus minus and out 2, and so on. Yeah, that will give us that. Now, we also have the schematic for the comparator tester, which is similar to this circuit. It's a little bit different. I did think, could I kind of build one circuit and switch between the two, but I think it's more hassle again. So I think I would then build 4 of the comparator circuits and put them on this side of the board. Okay, so we'll just draw that on here as well. Over here we will have our 4 module circuits again, if you like. It's very similar to this one, same sort of thing basically. And again, on the comparator testers, we have the same thing. We have 1 minus, 1 plus, 1 out, 2 minus, 2 plus, 2 out, and so on, 3 and 4. And again, those can all run up here. I can put my sockets again. Like so. Single, dual, quad, and these are comparators. These are op amps. Comparators. And then again, I can do the same sort of thing. I can put the surface mount adapters by each one. So this will test pretty much any op amp really. We need to add one more. We'll add this here. We'll put the single in line. This is those little 8-pin ones I showed you, which is wired pin for pin from that. We just have a little socket there for them. Okay. So with that, pretty much any op amp you can test, and with this, pretty much any comparator, I would think. Certainly LM397, that is the single. A common single one, and there will be some compatible ones with that. LM393, this is a dual. LM339, yeah, 339, this is the quad. So we can test those in there, and compatible pin for pin compatibles with that. So we have quite a nice tester coming along now. What we can also do is in the middle of this Vero board, I'm sure there'll be space, we can mount one of these. It could be off the board, or we can stick it, glue it to here. And now, where we have these rows of pins. There's 12 on each, effectively 3 for 1, 3 for 2, 3 for 3, 3 for 4. We can put some of these strips, okay, we can label them on the side probably. And now we can use DuPont cables. And we can strap them onto our little board here. So very easily now, if we have like a non-standard pinout chip, I think LM3900 was one, and maybe a few others, we can actually test them on there, and it wouldn't take long. These will actually, I'm just thinking, they won't go horizontally because that's the line of the Vero board. They'll actually go vertically in somewhere. However, I figure the wiring out, I'll figure it. Okay. So with one of these in as well, we then effectively can just strap wires to these, and if we have something non-standard, we can test that as well, and quite easily and quickly, certainly quicker than lashing together some other tester. We talked about a constant current source. I think this is a good idea. So the constant current sources are very similar. Simple circuit. Okay, like this. In, adjust, out. This is the LM317, okay, and the value of that resistor will set the constant current. Now our original circuit is using a 1K resistor. I had to think about this. The lowest voltage I can conceivably see you wanting to use on this tester is 5 volts. Most likely you're going to be using 9 volts or 12 volts. The most I can see you using is 30 volts. A lot of op amps will take plus and minus 15, which you can run them single-sided in this, or rather single voltage rail, it's 30 volts. So if we change the value of this resistor to a 3K3, on a 5 volt tester, we'll have about 1.5 milliamps flowing through the LED, which should be enough to turn it on. Okay, the 9 volt supply would give us about 2.75 milliamps. 12 volts is about 3.6 milliamps, and on 30 volts it's 9 milliamps. So on that whole range of voltage, that single resistor is fine. It'll just be a bit brighter on the higher voltage. Okay, to do that, we just need to select the value of this resistor. I worked it out, so it's, if we go, for example, a 20 milliamp setting, which should be good enough for testing on these voltages and possibly that one as well, then the resistor is, this closest standard value is 62 ohms. It's actually 62.5. And if we have a 50 milliamp setting as well, that would cover at this voltage 9, 18, 20, 36 plus some for the op amp. So for a 50 milliamp constant current source, this is 20. For 50 milliamp, we have a close, it should be a 25 ohm, but we can put a 27 ohm. It's a standard value. To do that, the easiest way is just to put a switch. So we switch, so effectively we just have 2 resistors here, and we switch to whichever one we want. So the switch will switch that way or that way, okay? That's one way. Another way would be to use 2 resistors in series that add up to that, but it's a bit fiddly. We could do it, but a switch in here anyway. So simple switch and the 2 resistors. We can then select the constant current. I think that's a very good idea. So if we slip with these things or we plug something in the wrong way round, the chances are we won't blow it up, or there's a less likelihood. And if we have a short circuit device here, and if we run this from a battery, we're not going to put a short on our battery, okay? So I think those are very good modifications. Now, some of you are going to say, Rich, use a microcontroller and it's easier, less component counts. Well, what I'm going to say about this design is 2 things. 1, this is all discrete component, just resistors, a few diodes, LEDs, capacitors. None of the values are critical. If we put 50 volt capacitors here, maximum 50 volt working, this will work on the whole voltage range that we may want to use with op amps. That is not so easy with a microcontroller. If something goes wrong while we're testing something's short in the component we're testing, we're not going to damage this. I can't imagine how we can damage this, or certainly a more difficult proposition than with a microcontroller. So for two very good reasons there, I believe this should be done this way. Okay. Also, microcontroller, you probably have to go and buy one. You need to program it, blah, blah, blah. With this, you can put this together. I'd imagine any of you out of scrap components can put this together. The only thing you might need is the IC sockets and some of these little breakout boards. And you may find an innovative way of doing that. Yeah, okay. Again, if you want to have this, well, you could have the breadboard separate and just strap it on. If you want to stick one on here, you don't have one, buy one. I'm sure most of you have got a breadboard, so again, it makes it, you know, easy to do. We need a switch, just a single pole double throw switch. So everything about this is very simple. So that's the two reasons I think we should do it this way. One is voltage range, and two is it's very difficult to damage it. Yeah. I'll put together the prototype on Vero board. We can play with that next week. And if it's working, we'll then make a schematic diagram for this in a CAD program, PCB design layout program. Go for the instant quote, quick order PCBs. We just upload the Gerber file here, choose what color we would like. Yeah. And we are done. These little things then won't be extra adapters like this. They'll just be exposed pads on the board. We can have a nice silk screening that shows what we can test with it. And I think we have a very handy little tester there. I like to build this stuff, and I hope you do. If you can think of any other similar chips that this type of thing can test, no microcontrollers please, wide voltage range, discrete, let me know if you can see any extra functionality I can add to this. And if I can, I'll do it when I put the prototype together. Okay, thanks for watching. Thank you PCBWay for sponsoring this video, and we'll be designing the PCBs for it next week. And I look forward to seeing you all again soon on Learning Electronics Repair. Ciao for now, guys.